starts. But thank you everybody who has joined us this morning, to the people who joined early, the people who've just joined us. All of you are super welcome here today. So what we're going to be talking about today is coding. We're going to look at it in a new kind of light. There are a lot of myths around software and what software is. And what we want to make sure you do is, whether or not you have previously considered a career in coding or even wanted to try out coding, we hope that by the time you finish this webinar, you'll have a deeper understanding of what it is and see if you're curious to find out more. There's a lot of myths, like I mentioned earlier. One of them is that you need to already know coding in order to go into a career in coding or even to study software. But for codeX, you don't need to ever have coded before. Part of our application process will take you through those steps anyway. You don't need to love coding. You don't need to have done it in school. You may have done it in school and found it quite intimidating. And we've got a very different approach to how it's taught in schools. Which leads us to maths and science. It's the same thing. People believe that you need maths and science to be software developers. Many of our coders, I'd say most of our coders, don't have maths and science, and they graduate and they go on to careers in software. It's really just a different way of thinking. And so what we invite you to do is just be curious and find out what coding really is like. And maybe you will choose a career in tech, or you might choose to find out more after this webinar. So I want to start just a little bit with the webinar poll, just about who you all are, where you're from, how you've joined. Thank you very much for helping us with this. It helps us to make sure that we're reaching all of South Africa and that we are catering for the kinds of devices that you are joining from. Right. So the first thing I want you to do is test your reactions on Zoom. So if you're on a phone, you may see that the reactions are at the bottom of your screen over here, or they might be at the top of your screen over here. If you click on the little button that says reactions, sometimes you just click on more and the reactions pop up for themselves. And let's test that by everybody giving a round of applause. So can I ask you to just everybody give us a, yeah, that's it. Got a round of applause. Give yourselves a round of applause for joining us today. Fabulous. And we're going to use this because although this is a webinar, it's an interactive webinar. We want you to participate because that's really how we discover things. So thank you, and a round of applause to all of you from me as well. Okay, so let's get going. My name is Cara. I'm the CEO of Project codeX, and I am, well, codeX is here as a tertiary training institution to help people to develop the skills that they need to build sustainable careers in software, particularly people who are brand new to tech, who may not have previously done any coding. Our mission is both to develop software skills, but not just the technical skills, the whole workplace environment skills, to make sure that we are training highly employable youth in a career that has a huge amount of demand in it. And why we do this is a few reasons, but key amongst them is that software is changing the world. And you will know this. You will have seen in your lives that you're using more and more software. You're joining here today on a phone or a computer. Every part of our lives has some element of software in it. But most of the people who build software don't really understand the challenges that the majority of South Africans face. And that's a problem because the kinds of problems that we solve well are the ones that we understand the best. We understand the little nuances and why this is a problem. And you also need to know about this. When you have that kind of knowledge about a problem, you're the most successful trying to solve it. But if people who are building software don't understand those challenges, then many of the challenges and opportunities facing the South African audience are not being addressed in software. And the people who know how to solve the problem often either don't know how to code yet or think software is not for them. And we're here to make a change to that. We do this by building a rapid learning approach. So the way in which we train people is very deep skills as quickly as is possible. It's based on real world software practices. So there's technical skill, there's agile practice, which is the kinds of things that software teams do to build good quality software. It's the way we communicate and the way that we write the code that allows us to respond to change quickly and work together well. And a fundamental focus on personal development to make sure that when you finish a year of codeX, you're ready to join the working world with all of the different kinds of challenges and differences that the working world may present to us. We spend a year really focusing on that. And the year leads either to employment or to deeper training. And that's the same whether you're brand new to tech or you already know some coding. So more than 50% of our coders have never coded before when they join a codeX program, and only about 10% have quite a lot of experience with coding, and they still have the same level of challenge and excitement and learning through the program and exit with employable skills. And what kind of careers might that lead to? So there are, as I'm sure you're now aware, since the pandemic, it's even more than it ever used to be. Software is pervasive in every industry. In retail, it's shopping online, but then it's also kind of working out how to promote, who to target for promotions. What kind of buying trends are we seeing? How can we amplify those? Entertainment, it's YouTube, it's Deezer, it's Spotify, Netflix, Showmax, all of our entertainment is coming to us on our devices. Not all of it, large amounts of it. Also games, kind of entertainment and gaming are related. In terms of medical, our medical records have been online for a long time. South Africa has been ahead of the world in many ways, having our data online. But also we use medical data to look at what kind of treatments are more successful and less successful, and be able to diagnose diseases faster and recommend treatment plans better. Manufacturing, the factory machines are all running off software. It's also orders and fulfillment and all of the kind of delivery side of things. Agriculture is super interesting. It's monitoring when our crops are being watered, taking photos of crops, being able to identify, should we increase the watering? Should we change how we're treating things? Is there an area with disease? I spoke to a couple of people last year who were exploring taking photographs of cattle and being able to do early detection of cattle diseases, which is super interesting and super relevant in South Africa. Education, for those of you who've been involved in education since the pandemic, you'll know that a lot of it is online, and more of it is going online, just information sources and ways in which we connect. And also, if you like gaming, gaming is also an industry that is very worth exploring. And there just are many, many more. And once you're in the career, it's not just coding. So to a certain extent, it's a really good place to start with coding. But there are also other specializations. So I like to start with UX design. That's called user experience design. And user experience is when, and I don't know if you've had this situation where you're working on your phone or you're working on your computer and you're on a website and you're like, I don't know where to go next. I don't understand what I need to do now. It's not very clear to me. And that shows us that the person who built it didn't have a deep understanding of how their customer was going to use their application. So user experience design is sitting down with a customer and talking to them and asking them, show me how you would do this. What do you expect to happen next? To get and design much better quality apps. And the apps that you have, that you're using, that you really like using, a lot of those have a huge amount of UX behind them. Then there's the coding. So you've kind of understood what your customer is looking for, and you've got some coding going on, and you've got some design to make sure it kind of looks beautiful. And then there's systems analysis. And this is a bit of an advanced career. Once you've been working for a while, you start to realize that one application speaks to another application. If you're on a phone now, your phone has an operating system, or your computer has an operating system, and then you've got different apps in it, and different apps give you different permissions, so they talk to each other. So systems analysis kind of goes, what are all the pieces in the system, and how do we make it work faster and use less data and be, from a systems perspective, more comfortable to use. Machine learning, some of you may have heard of. Machine learning is also under the buzzword 4IR, the fourth industrial revolution, is when we're using lots and lots and lots of data that people are producing, lots of information. It's our medical records, it's our agriculture, all of those things. Also, how and why we use different software applications. It might be the shopping app, it might be YouTube. All of that is looking at how our customers are working and working out patterns and trends. So machine learning is the part of software that looks at trends and looks to understand trends, to predict where things might be going and to find better ways of doing things. So that's learning, not from machines, but from algorithms reading what people are doing. So we call that a machine. And then DevOps and deployment are when we've got some code sitting on a computer, and it's got to go off the computer of one developer, and a whole lot of developers' code needs to be combined, and then it's got to be put into a testing environment, then it's got to be retested in another environment, and then it goes out to production, which is where you all are now. You're on the end of a production deploy from Zoom and from Google Slides. So that process of coming from somebody's laptop or computer into us using it online is called DevOps or deployment, and it's its own specialization. And there are many more careers. When I started in software lots and lots of years ago, DevOps and machine learning weren't really things that we talked about. We did talk about data analysis, and machine learning has grown out of that. UX design is only just it's only grown up in the last 10 years. And so it wasn't much of a thing when I started. This is a career that keeps changing as the world keeps changing. It's a truly rich environment to go into. So now we've talked about the kinds of careers and what it is. Now I want to talk to you about what coding really is and dispel some of those myths. So we're going to look at how code works. We can do that without using, aside from your laptop, your emoji reactions, we're not going to use coding or computers to understand it. We're going to play a game that's kind of used to be thumbs up, thumbs down, but with the emoji, we don't get thumbs down. So we've got some other emojis going on in the webinars. And then we're going to look at scoring and how scoring works. And once we've done that, I'm going to talk to you about 2 online coding platforms that help you to learn how to code, and then briefly talk about how to apply to codeX if you're keen. So first off, what is coding? It's a different way of looking at the world. And specifically, it is using languages to create instructions that computers can follow. That's it. Using languages that create instructions for computers to follow. And what's important about this is that computers and people are different. We process information differently. So computers are able to follow complicated instructions very well, very quickly, as long as they understand them. If they've received instructions in a format they can understand, they follow it super quick, no challenges, off they go. But they can't make assumptions or decisions. They can't say, I want to, if this, then that they can only follow if they experience something they don't understand. That's when your computer goes and your app shuts down, or you get a big error. And what's happened there is something has happened in the orders and the instructions it's received that it can't process, and it just shuts down. People, on the other hand, are super good at making assumptions and decisions. We look at data and we're like, okay, well, we're seeing this, so we can assume these things and we can do those things with that information. We're really good at that. We can follow instructions. You may have noticed that about yourselves and your friends, but we actually take some time to think about them because we're always running them through our assumptions and decisions first. So somebody else has to do something. We often want to know why and what the purpose is, and then we'll decide how we want going to do it. Computers, they don't do that so much. They're just like, oh, okay, you want me to do this? We've got it. And what's important to know is in the world we live in now, we need both. I'm sure that you're aware of that. Part of you being here is brought that is part of awareness that we can't actually live in a world without computers anymore. And there certainly were times when people could live without computers, but to thrive in the modern world, we need both computers and people. So now we're going to look at how coding decisions work. And for those people who've joined us recently, we're going to use the emoji reactions on your phone or your computer. So on Zoom, you'll either see a little icon that says emoji or reactions, or under the more button, you'll see some reactions emoji at the bottom that you can react. And what we're going to do, there we go, thanks. We're going to explore the idea that if something happens, how should we respond? And so what we're going to do is, if I give you a thumbs up, then I want you to find the clapping emoji and give me that. So I'm going to try that out. Here we go. Here's my thumbs up. There we go. We've got some hands clapping. Some more hands clapping, right? Pretty cool. Okay, fairly simple. We just have to find it and execute on it. Now we're going to try that the other way around. So I'm going to give you a clapping symbol, and I'm going to ask you to give me a thumbs up. So did I do a clapping symbol? Let's do that again. That's me clapping over there. We've got all the thumbs up. Okay, we're going to try that again. I'm just going to give you okay, I'm doing thumbs up now. I've done a thumbs up. Yeah, some clapping. So we have to change, and we have to think about it as we change our system. What about if I do this? What if I give you that kind of symbol? Okay, we've got a surprised face in surprise, some laughing, some surprise. Okay, so we've gone for some other emojis. So what happened now is you made some assumptions, right? If it was a computer, the computer can't actually process that information if it doesn't know what to do. Whereas people, we're super good at it. We're like, okay, cool, give us that. Maybe we should try these things. So for the computer to work, we have to give it an else condition. So we've given one condition. If Kara does this, I do that. If Kara does that, I do this. If anything else happens, then you can choose any other emoji, or you must do a heart, or you must do a celebration, whatever it is. So we've kind of just, and you've implemented it even before we said it, all sorts of other emoji, because, and that's how it went. So what we're doing is we're making sure that there's a condition and there's another condition, but if anything else happens, the computer won't break because it has a response available to it. So that's a fairly simple scenario. We're going to try this now with something a little bit more complex, and scoring can be super complex. If you think about tennis or rugby or cricket, they've all got strange scoring things. Like tennis starts with 0, but 0 isn't called 0, it's called love. And if you score 1 point, it goes to 15. If you score 2 points, it goes to 30. And if you score 3 points, it then goes to 40. Not 45, 40. And then if your partner reaches the same amount of you and you're equal, it's called juice. And then you can go advantage juice, and it's very strange. Rugby, sometimes when you kick the ball between the posts, it's 2, and sometimes it's 3 and or points. And the circumstance around that tell us if this happened when you kick the ball, then it's 2 points. And if that happened, then it's 3 points. And if you put the ball down over the line, it gets these other points. Cricket as well, you can run between the wickets to score points, but if you hit the ball out of the park, you might score a 4 or you might score a 6. And it's if the ball touches the grass that you score a 4, but if it doesn't touch the grass, you score a 6. So all of these are rules. And hopefully when you look at sport again in future, you'll be thinking about it as if then. These are conditions. These are really just coding conditions. And we're going to try this out with cards. And we're going to use a made-up game where you score points depending on what cards you get. So the first, in the scoring, we're going to say if the card is red, you're going to score 1 for the cats. And if the card is over 8, you're going to score 1 for elephants, and then we'll add up our scores. So if these are our 3 cards, we've got a 6 of diamonds, a 5 of spades, and a 10 of spades. Then we can run this through our rules. So we can say if it's red, so the 6 of diamonds is red, we can say yes, score 1 for the cats. For the 5, it's not red, it's not over 8, so it doesn't fulfill any of our conditions, so we're just going to leave that alone. And if it's 10, so if it's over 8, we're going to score 1 for the elephants, and then we've got 2 scores. Fairly simple, understandable. If everybody's happy at the moment, you can give me like a hands clap or a thumbs up just to, yeah, cool, thank you. Oh, we've got celebrations as well. Lovely. Okay. So now we're going to try that with some more cards. Okay, remember our scoring rules are, if the card is red, score 1 cat. If the card is 8, score an elephant, over 8, score an elephant. Okay, cool. So now let's come and have a look at our 10. Okay, 10 of spades, it is over 8. Okay, so we can score an elephant for that. 6 of diamonds is red. We can score a cat for that. 10 of diamonds is both red and over 8. What are we going to do with that? And now what's this? Is this a high card, a high in the pack card, or is it a letter card with no value? What do we do with this? And this? Is this even part, like is the joker even part of the pack? Nobody told me about jokers. What must I do with jokers? So what happens when we have some simple rules to run is we often quickly find that they don't cater for all scenarios. So what do we do with that? So if the card is red and over 8, both are valid. We can score that you only score once. If it's just red, you stop there. Or you can score for red and over 8. It's an and condition, you double count. We can do either, they're both valid. So what happens is we decide. People decide. And then we create the instructions for our computers to follow. And that's really what most of software is about. It's kind of going, what do we do if this happens? And so we're going to do this now as a group. So I'm just going to change my display so that we can interact with this. What I want you to do is use your emojis. If you think we should only score once, if the card is red, give me a celebration figure emoji. And if you think we should score for both red and over 8, give me a hands clapping emoji. So you can vote with your emoji. And it looks like for the most part, we're in the hands clapping thing. So what I'm going to do now is I'm going to delete this one and say, this is where we as a group today voted. Score for both scenarios. Cool. Now, what about the joker? So some people say the joker is not part of the deck, so we don't score for it. If you're like that, just give me a hands clapping symbol. And some people say, but if it's red, we can count it. Give me a celebration symbol. And I'm just going to count on average. Oh, this one's a bit of a split vote. Okay, Okay, we're 50-50. So what we do when it's 50-50 is I'm going to ask everybody to put hands off the emoji. And then the first one to give me an emoji, thumbs up isn't is off the charts. First one to give me another one is a celebration. So we've decided that if the card is red, we're going to do it. Now, obviously, first to vote is not always the best way to make a decision. And if there's a real implication in the space that we're working in, we actually need to sit down and talk about it. So for example, if you're playing a game where jokers have a valid role, then, or even if it's snap and you use both jokers and you snap on the jokers, or you use the joker as a wild card and joker will snap with everything, then people want to count it in. But if you're playing a game like solitaire where the joker pops up and you're like, oh, let's just run the game, then people want it out, right? So we need to think about what is the condition that we are counting the joker for, and then decide. So here we just did it by first vote, but that's how we would do it when it really matters. Okay, same thing. Vote for me for picture cards. If it's a number that's bigger than 10, give me a celebration. A party sign. And if it's a letter with no value, give me a hands clapping. Okay, we're definitely more in the numbers bigger than 10 version. Great. Thank you everybody for casting your votes. And lastly, aces. Are they low? Is it a score of 1? Or are they the highest card in the deck and they're bigger than 10? If you're a score of 1, give me a hands clapping. If it's a bigger than 10, give me a celebration. Okay, we're definitely in the low side here. Okay, so there are decisions, right? Remember, people decide. Now we're going to implement them. So on our next, so I just want to say there will always be things we didn't anticipate. And what happened in this one is where there were cards we didn't anticipate or we couldn't process, our computer program would have fried. So you'll remember that we talked about the else option. Now we're introducing an else bucket. So if our card is red, score 1 for cats. If our card is over 8, we've got an elephant, score an elephant. For everything else, we're going to score 1 giraffe. And then we'll add up our total scores. So, but just before we start, we have to actually implement our decisions. So if we go back to this one, we said when it's red and over 8, we're going to score for both. So we're going to go here and we say, okay, we're going to delete this one and score for red and over 8. And then we said we would count jokers if they're red and picture cards if they're bigger than 10. So we can delete those ones, but aces are low and we'll only score 1. Okay, so now we've got our decisions and our rules about exceptions. So now we can go, okay, 10 of spades, it's not red, it is over 8, it gets an elephant, cool. 6 of diamonds, it is red, yes. Is it over 8? No, it's just 1 cat. King of clubs, it's a picture card, it's bigger than 10, so it will score 1 elephant. It's not red, but it is over 10. Our joker is, we have agreed to count if it's red, so we can say yes, it does count. It's 1 cat, but it's not of a value. And our 10 is both red and over 8, so we've got 1 cat and 1 elephant. And here we have no giraffes. Everything that is in here we have counted. If we'd said that the picture card has no value, it would have been a giraffe. If we'd said that the joker doesn't count, it would have been a giraffe. And if we'd had an ace, it would have been a giraffe. So there we go. And our total scores are 6. So well done, everybody. You've just created and I have run your first program. And that's really how the scoring works. So now another question for you. How long did that take? If you think it took less than 30 seconds, give me a heart. If you think that it took less than 2 minutes, give me a clapping. More than 2 minutes, a thumbs up. And more than 5 minutes, a surprised face. How long did that take you? So less than 30 seconds, we've got a few votes. More than 5 minutes, we got a few votes. We've got a few less than 2 minutes. We've got a full range, and we've got an interesting, oh, that's a double at the same time. We've got a full range of these somewhere around less than 2 minutes. Now, let's take that a little bit further. What about if we had 40 cards? How long do you think that would take? Do you think we could do the 40 cards in less than 2 minutes? More than 2 minutes? More than 5 minutes? So some people will say it won't take us 5, but it could take us more than 2. That's cool. What if we have 80 cards or 160 cards? We're into the laughing. We're right off the charts here. Okay, so we're definitely more than 5 minutes if we're doing it. And also we'll probably get a bit sick of cards because we have emotional responses to the work we're doing, right? What if we had a computer program? What if a computer program was running all of this? How long would it take, do you think? Less. Much less than 30 seconds. In fact, it should just take a couple of seconds. Also, do you think the computer program would be like, no, I'm bored, I'm going to stop now, don't give me another 160 cards? It's just like, oh, you got more cards, run the program, here we go. It's all done, okay? So the computers help us to do things. They can follow complicated instructions very well, very quickly, as long as they understand them. But they cannot make assumptions or decisions. People are super good at making assumptions and decisions and can follow instructions, but we run them through our assumption and decision-making framework. So it takes us a little bit of time to complete the instructions. And we do get bored where computers very seldom, or I am unaware of a time where a computer gets bored. And in our modern world, we need both in order to be able to thrive. So now that we know a little bit about how the coding decisions work, I wanted to start looking at those 2 platforms I mentioned earlier of learning to code online. And we're going to look at 2 different platforms. It's Hour of Code and Free Code Camp. What we're doing when we're using online platforms is we're learning how to write instructions for computers. And I'm also going to show you how these 2 platforms I'm showing you can be done on phones. They're not the most brilliant on phones, but they can be done on phones. So we're going to start with Hour of Code. It's also known as code.org. Code.org is the URL, but it's known generally as Hour of Code because there are a whole lot of 1-hour exercises that help us to learn. What I want you to be aware of is in these online platforms, the instructions are given to us. We don't have to make them up, but they were made up originally by somebody else. Somebody else thought about how do we do this? What should we ask? What instructions should we give? Okay, so it's not that they magically, the computer generates these suggestions or these ideas, humans made them. And in Hour of Code, what we have to do is we've got all these blocks that tell us what the order should be, what our character should do, should move up, move down, move left, move right. And our responsibility is to get the instructions, follow them in order to meet the required challenge. And I'm going to show you how that works over here. So when you start on Hour of Code, you get this page that gives you instructions, add a second command to move your code, then click to run it. And our instruction is, we need this scrap metal, and they've got a little drawing of the scrap metal. Can you get it? And you click OK, and you can see a little bit more of the screen. There are also 3 dots next to the screen. So if it's all collapsed, it's quite hard to see, particularly on a phone. So if you can find those 3 dots and pull it out, you can see the screen much better. Super useful, because now we can see more about what's happening here. So our mission is to move BB8 from here to there. And we've got in here our workspace where our commands are all going to go, and our toolbox, which is all the commands we can use. And I'm going to run, we've got move right in there at the moment, and I'm going to run it to show you what happens. And you get some cool sound effects. And he's moved right, or it's moved right, but is not at the scrap metal. So now we're going to try this together. So we're going to move, and what I want you to do is using your emoji again. It's 1, 2, 3, and 4. It should be ordered that way for you. Hands clapping for up, move down, thumbs up, heart for left, laughing for right. A little bit hard to remember, but what are we going to do now? We're going to move right. I had one laughing. We've got another laughing. Let's pull our move right in. And then we're going to run it. There we go. An unexpected bonus of this exercise is it looks like everybody's laughing and having fun. So that's cool. Okay, so now you've completed it and it was successful and we got all the sound feedback. And RF Code will show you what lines of code you just wrote. So these are called methods. This is a method that somebody's going to follow. Method move right and then move right again. So your BB8 has followed these two instructions. We're going to do this again. Move on to the next one. And then we need more scrap metal BB8. It's this symbol now. Can you get all the metal in this area? So remembering that up is hands clapping, down is thumbs up, left is hearts, and right is laughing. What do we do to get to this, these two? So we've got another laughing, which is, what do we say laughing is? Move right. Move right, okay? And then what do we do? Then we've got a thumbs up, which is move down, move down. And then what do we do? We've got a move right and we've got some move down. Okay, so I'm going to pull in the move down because that's the majority. And I'm going to run it. Okay. And there we've got these 4 commands. Move right, move down, move down. Pretty cool. But I want to show you something else. And this is really important. The difference between software and puzzles is there are often many ways to solve a problem. So if we start over, we can give it more commands. So if we say move right, then move right, then move right again, then move down, then move down, then move left. We're going right, 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 down, down, left, right? We've actually still met the objectives. There are many ways to solve software problems. It's more of a personal choice and a creative choice, and it depends on the constraints. If you're expected to write more, this would work. If you're expected to write less, the other way would work. But please be aware that there is not only one right way to solve a problem in software. One of the biggest difference between software and most of the industries we work in is actually it's got that creative thing going on that we can make decisions that are not necessarily what others would choose. The next one I want to talk about is JavaScript JavaScript. And again, so Free Codecamp, sorry, Free Codecamp is the other platform. Again, the instructions are given to us. We don't have to make them up because another human being made them up at another time. When we're using Free Codecamp, when we're looking at Star Wars, we're understanding the kinds of ways that computers process information, the kinds of instructions we generate. When we're looking at Free Code Camp, we're learning how to write those instructions ourselves. We're learning the language of computers so that we can give it instructions. And JavaScript is the language of the web, so it's on all of our browsers and so on. So we like JavaScript because it's very quick to give us results. Free Code Camp basically shows us more about how code instructions are created. And I'm just going to show you what it looks like. We start with basic JavaScript, and in Free Code Camp on a computer, we've got instructions on the left here. This is what the instruction you want to write, and you can make lots of comments. And you can make 1-line comments and 2-line comments, and it gives us the examples and the instructions and lets us run the test. So we've got this is a comment on a single line, and these are the multiplying ones, and I'm going to say some comment here, and it just sits between a line and a star and a line and a star, and the single line is just starts with 2 lines. Okay, cool. Run the tests. And I've got the first one down. I'm 0% complete on JavaScript. Please, if you're working through these on a codex exercises as an application, make sure you're signed in or your progress won't be saved. Then you can go to the next challenge and start to follow the instructions of how to create a variable. Okay, there's a lot of information that's in here. And sometimes, and if you're feeling confused, you can get a hint, you can watch a video, you can ask for help. I'm not sure what happens on that, but you can watch a video and get a hint. And for codex applicants, we have mentors available if you're stuck to help you understand, you know, if you tell us where you're stuck and what you've tried, we can help you get unstuck. On a phone, Free code can be done on a phone. I mean, R of code can be done on a phone in the same way. It's almost identical. But Free Code Camp on a phone is a little bit more of a challenge. We like Free Code Camp because they actually care about how little data, you know, trying to make it at least data consumption for you as possible. And they're one of the few places who have made it possible to complete it on a phone. So on this one, your info that on a screen has got quite a lot of space. Your info is on one tab, and you've got tabs at the top. So you've got all of your instructions are in there, and you'll need to scroll down a bit to find it. Then to write the code, it's in a separate tab. So you'll have to remember the instructions to write the code, but you can go back and forth. And then when you run the tests, it'll give you a separate thing. So it is possible on a phone. It's not as nice as on a computer, but it does mean that people can start. They can start playing and start experimenting. And for us, the important thing is just try it. Just see. Do you like it? Does it feel good? Most of the time we've been intimidated by software information instead of made it kind of seeing if we find it fun. So our mission is to see if you would like to, to find out, to invite you to find out if you enjoy it. So that's about coding. Coding, we learn it sometimes just to be creative, but sometimes to actually become employed as a web developer. So what you want to know is you don't need to know coding already to start being a web developer. You just learn code as you go. But be aware while you're learning that if you want to be employable, you need to be able to show what you have learned. You need to be able to show people, an employer, an interviewer, the things that you have learned. So a portfolio of projects, show people what you've actually built. Interviewer looks at it and goes, why did you build that? That's very interesting. So you want to be able to answer questions about how you made it. So what did you use JavaScript? Did you use HTML? Did you use CSS? Why you chose to make that, or why you chose to make it in that way. So when in those interviews, you're asking questions about the decisions that you've made, what to build and why to build it. And there's decisions and assumptions. And having experience working on a team is a real benefit when you're talking to an interviewer, because then you understand the kinds of dynamics that you have going on in teams, particularly when people's decisions aren't all the same decision and you have to kind of come to agreement together. Most of working on a team is building something faster than an individual can make, but also then having to agree with each other about the decisions you're making. So if you have experience with that, employers really like it. So RF Code will get you familiar on how to structure code. You can make websites using JavaScript, HTML, and CSS, those 3 languages. And Free Code Camp is a really nice place to start learning languages. The way codeX works is for people who apply to codeX, we ask them to do JavaScript, HTML, and CSS on Free Code Camp. So they've got basics down and you know that you kind of like this. It's important that you like it to be able to persevere when things get hard. In our foundation year and the Agile Web Developer year, our focus is on making web apps and building team experience. And for those people who do a second year, it's Java or C# or web frameworks. It's a more advanced program, exploring the same concepts more deeply, always with projects. So you're always building things as you go along. What the Agile Web Developer, the skills that it covers, the technical skills, is about the web apps. That's making websites that show changing information. So if your information doesn't change, you don't necessarily, you just got a website, not a web app. But if you're doing things like prices that change, or weather apps where the weather's changing and it gets updated every 3 hours, or your ESCOM push app where things get changed so randomly, so quickly, you want to be able to make change quickly. So in this case, we think about how our customer is going to read it. Our customer is going to collect data and give it see what we return. The front end is what you're looking at right now. It's the browser or the app interface where the customer interacts with it. Typically, HTML, CSS, and Java are what those are compiled of. And then the back end is where all of our history lies. So if I if I sign into an app and then I come back the next day and all my information is gone, then their backend isn't properly set up. But if it's still there, then they've got a database that's holding the memory and they're remembering who I am and the kinds of decisions I've made before. That's the backend. And both of these together are what make up the codeX Agile Web Developer program, along with the Agile practice and the personal development I mentioned earlier. So if you want to get more information about applying to codeX, I'm just going to put this into the chat section here. So that bring back chat. Okay. Everyone. So if you want for more info about applying to codeX, if you fill out that form, it will generate a set of instructions for you to follow and it'll go to your email. If you want to scan the QR code now quickly, you can, but I'm going to say very quickly because I'm going to move on. So the way it works is when you apply to codeX, the first step is an application form, which you'll find on our website under apply, with a whole lot of info about what you need to do and what the processes all are. When you click on apply now, it opens up a form. Please note for 2023, the applications, this form must be completed by next week, Friday. After that, we stop taking forms because there are so many more steps after it. But that's fine because there's another year and it is quite late to apply for 2023, but you can start thinking about applying for 2024 as well. And in this application form, there are 5 sections. It's your details about your education and work, something about you, some financial information, and some puzzle and creative questions we ask you. Once you've done that, you will automatically get an email. Please check your email, check your junk mail. It'll show you how to set up a free Code Camp account and which 3 courses we want you to do. People who complete the 3 courses in time to attend a boot camp will invite to an interview. And that interview will look at, did you understand the concept? The focus on the interview is JavaScript. I got this from my mentors on Saturday. I wasn't aware of that until Saturday. The focus in the interview is JavaScript. Do you understand the concepts that have been covered in that course? They'll ask you to define a couple of the concepts, explain what we do with them. For people who we can see understood those concepts, we progress to a 2-week boot camp. And in that boot camp, we take what you've already learned and we ask you to complete, to make it yourself. We are stopping now. So Tapelo, I'm sorry about your load shedding. I hope you don't miss too much, but you have most of the information available to you. Throughout this process, we provide support. So you can WhatsApp us or email us if you've got a challenge. Our last Discover Coding on site is on Saturday this week. So if you know anybody in Cape Town, tell them to sign up and come and experience it interactively. Otherwise, we'll do more online. And ultimately, what I want you to leave with this section with is the knowledge that you can choose a career in tech. You don't need a coding background. You don't need maths and science. You can just be curious and find out what it's really like.